Okay, in this video I'm going to talk through the latest ground force construction design. There's been previous videos you might have seen. This one's up to date and it's based on the exact containers and the steel work that we've procured. So let's start with the overview. Actually looking at this one. Here's the first one I've already done, which is containers in an aircraft. So this has been done before with great success. This is a new one. It's very much the same thing, but with 2 containers higher, which has a bit more complexity to it. So let's start with the ground floor. So down here, what we'll be doing, firstly the site, we're on a slight slope. It's about a 500mm offset. We've used a theodolite to establish that. What we need is a foundation here for the north tower, a foundation here for the 3 columns, and a foundation here for the south tower. Now the north tower and the south tower are all 20-foot ISO containers, and to deal with the offset of the height, we're going to put some vertical columns in above the 20-foot containers at the rear, thereby creating a bed of these RSJs. All the RSJs I'm using are 150 wide by 450mm high by 6mm thickness. That's wildly over-engineered for what we're doing, but I like having a big factor of safety, and throwing more metal at it gives us a belt and braces approach, which I like. Now, it's not shown here, but between these RSJs we'll have some purlins, mezzanine style ones. They'll be on 500mm centers, and that will hold the decking. So we have our bed here, nice and flat. And then on top of that, we then put the next line of containers, which are 20 foot in the north tower, 40 foot in the south tower, all high cube structures. Now, on this 40 footer here, we need to add an additional vertical column, which will be a series of sections of metal that connect the RSJ to the underside of the floor beam, then with a box section welded inside the container up to the transom, with more steel that then connects it to the RSJ above. You'll see why in a minute. Over here's the decking I talked about, and here's the containers. We will be reducing these window sizes, but there will be windows within them. Now, our methodology with these windows is to use a gusset steel plate in the corners, there and there, there and there. And also this green section will be a 60 by 60mm box section on a 4mm wall, thereby making the container stronger as a result of removing the corrugation than it was before, so we can therefore assume that they work to the standard ISO specifications. Now, if we move up here, you can see the slightly more complex steelwork layout. What we've got here is this RSJ goes onto this corner casting and this corner casting, and there's a 2-point cantilever sticking out. Same on this one here. And then we do an RSJ connecting across here, which will be done with bolted or welded cleats, and the rest of the containers can continue on from the corner posts. Underneath each corner post, we will have a large plate, which will be a 400mm by 400mm, 10mm steel plate, thus allowing multiple RSJs to sit on it. All of these will be connected with a welded cleat. Again, belt and braces way over the top. So that's that. Next level up, second floor. Pretty much the same again. 20-foot containers at the front, 20-foot containers at the back. And now you'll see why we need this column here, because that column is both taking the load of this RSJ coming out for the cantilever balcony, but also taking the compressive load of the corner post of the 20-footer above. I didn't want to omit that, because then we would be putting a point load on the center of what would have been a 12-meter span. So that column's very, very important. Okay, yep, more steel work up here. Similar idea, RSJ cantilevers out, with more spans going between the corner posts. And this bit here being where the nose landing gear of the aircraft sits. Crucially, this RSJ is spread across both corner posts. So we're just always spreading the load out across the entire structure. Let's go up to the top floor now. You'll see now that we have a decking that needs to be redrawn, but the decking would come back to here, and the RSJs for the nose landing gear stick out through the decking, and the aircraft sits on top. The aircraft's actually very light. It's about 32 ton with everything inside it. So for its area, very light. And strapping these down is important. So the way we've done it with the last one is we've used 4, I think it was 3-ton steels, and the nose landing gear strapped down onto welded plate eyes here. And at the back, similar things go up to the landing gear attachment points, which can obviously take the full load of the aircraft with impact. So there's ample strength of those attachment points. In this area here, you'll note again, we're spreading out the load across as many corner posts as possible and then creating a dolly arrangement for the aircraft to sit on here. Additionally, which might be outside the scope of this, is we've cantilevered out the RSJs here so that we can then extend a balcony up to here. I'm still working the design of that, so disregard that for now. It's the containers and the RSJs which I want to draw attention to. That should give you a good overview. Now, in terms of attachment, we're going to be chaining the aircraft to the steelwork and the containers. All steelwork connection will be flat plate steel, probably 60 mil wide by 8 mil flat plate, connecting the RSJs to the container, welded, same down here and so on. So everything's tied together, welded in situ. It's not demountable, so welding in situ is totally fine. We've got good access equipment as well. We could bolt, of course, but I think welding is much better for this application. One other detail, because I'm conscious of the expansion and construction of the whole structure, I calculate 12.3 millimeters across the whole length. We don't want the whole structure walking around. So in my head, these containers would be sitting on the concrete, but these columns in the middle would be very, very firmly bonded into the steelwork. And that's it. That's where I'm at. Obviously, a few more design details, but the overall container and RSJ structure is as I wish for it to be built. Keen to hear thoughts and feedback. Thank you.